Good morning, dear children. In the last video, we have discussed about the laws of refraction. Do you remember which are the laws? How many laws were there? We had two laws of refraction, isn't it? So, which were they? First one was incident ray, refracted ray, and the normal lies on the same plane. And the second one was known as Snell's law, isn't it? That is, the ratio of sine of the angle of incidence to sine of the angle of refraction is a constant for a given pair of medium and given color of light. So this is what we learned, isn't it? Now we are going to prove this. So our next topic is experimental verification of laws of refraction. Last year we have learned this with reflection. Do you remember? With reflection of light, after studying the laws of reflection, we have learned about the experimental verification of reflection. Similar to that, here we are going to prove the laws of refraction. Okay. So we'll check how we can prove that. For that, first we'll be taking a chart paper and a rectangular glass slab. Okay. So we'll be taking a rectangular glass slab. Keep this rectangular glass slab on this chart paper and draw the outline. That is our first step. Okay. So take a rectangular glass slab, keep it on the chart paper and draw its outline. Now the next thing is just remove this rectangular glass slab. So we'll be getting a rectangle there, isn't it? Now draw the normal on the face. Let me name this as ABCD. So on the face AB, we have to draw the normal. Then you can draw the incident ray here. Using the pencil and the ruler, you can draw the incident ray and you can just mark it or measure the angle of this. What is the name given for this angle? Angle between incident ray and normal is known as angle of incidence, isn't it? So let this angle be 40 degree. So we are just measuring using a protractor. We will take 40 degree and that will be the angle of incidence here. Is it clear? So we have drawn the normal on this rectangle. After that, what did we do? We have used a protractor and took 40 degree and then we have drawn the incident ray. Now, the next thing is take the rectangular glass slab back and keep it on its place. Okay, keep the rectangular glass slab on its place. Then take two pins and just put those two pins on this incident ray. So we have kept our rectangular glass slab back in its position. Then take two pins and keep those two pins on the incident ray. Now what is our next thing? Already we learned it for reflection. We will be standing on the other side. Then we have to look through the rectangular glass slab. So when we look through the rectangular glass slab, you will be seeing these two pins, isn't it? Now take two more pins and keep it such that when we look through the rectangular glass slab, all the four pins comes in the same line. Now I have put two dots here and this is not in the same line. Why? Here we have to look through the rectangular glass slab. When you are looking through the rectangular glass slab, you can see these two pins. Then take two more pins and keep it such that all the four pins comes in the same straight line. Now what is the next thing? Just remove the rectangular glass slab. Then we have to join this. Okay. So when we are joining, I don't know whether we will get it since without any measurement I am drawing this. Okay. And we have to join these things. Since the ray is moving from rarer medium to denser medium, it bends towards the normal. Here it is moving from both denser to rarer. So it is moving away from the normal. Okay. So I think it looks almost same. I'll put my 2 pins here. Okay. Then only it will be correct. So what you have to do is first join these two dots we got here now for the pins. So just join that with the face DC. After that you have to join these 2 points. Okay. So we will be joining these 2 points. Here we will be having the normal. Clear? Now, the next thing is you have to measure the angle of refraction. So, which is the angle of refraction? This is our angle of refraction. This is I and this will be R. Isn't it? So, just measure the value of angle R. Now, listen. What was our first law of refraction? Incident ray, refracted ray and the and the normal lies on the same plane. So are they on the same plane? Yes, isn't it? This is our incident ray. This is our refracted ray. Our refracted ray is not clear. I'll just draw it properly. Okay. So this is our angle of refraction. So the incident ray, refracted ray and the normal, all the 3 things lies on the same plane. Okay, so first law is satisfied. Now which was our second law? Sine of the ratio of sine of the angle of incidence to sine of the angle of refraction is a constant, isn't it? So we know that sine I angle I is equal to 40 degree. So we have the Clark's table, and from that you will be getting the values of trigonometric relations. I think already you have learned it in maths, or using scientific calculator we will be getting the value. So what we have to do is find the value of sine 40. Then here also we are measuring the value. So measure the value, measure the angle and find the value of that. Okay. Then we have sine I and sine R. Then what is our next step? Mu is equal to sine I by sine R. So divide sine I with sine R. Then you will be getting a value. Okay. So let the value be 1.416. We got a value. Now the next thing is repeat the experiment. Same thing with another value of angle of incidence. Here we have taken angle of incidence as 40 degree. Next you can take angle of incidence as 50 degree. So what? Again take the rectangular glass slab, draw the outline, draw the normal, then measure for 50 degree and then draw the incident ray. Keep 2 pins. Then after that keep the rectangular glass slab on its place. Look from the other side. Take 2 more pins and keep it such that all the 4 pins comes in the same straight line. Then remove the glass slab. Measure the angle of refraction, and before that what you should do? Just join these 2 lines with the face DC. Then join these 2. Then only you can measure the value of angle R. So once you get angle R, I and R will be known. Calculate sine I and sine R, then divide it. So this is the second case. In the second case, instead of 40 degree, we have taken it as 50 degree, isn't it? So with that, since the angle of incidence is 50 degree, there will be a change in the angle of refraction also. You will be getting some other value for angle of refraction. Get the value of sine I and sine R and divide it. In that case also, you will be getting the value of refractive index as same thing. Okay. So, same value we will be getting for refractive index. Is it clear? So, what can you prove from this, or what can you conclude from this? The ratio of sine of the angle of incidence to sine of the angle of refraction is a constant. So we have changed. We can repeat the experiment with different values of angle of incidence. In all the cases, what you can say, the value of IR, sin I or sin R will be different, but the value sin I by sin R or refractive index will be always a constant. And this is our Snell's law. Okay, so is it clear how to prove laws of refraction? Okay, so we have to repeat it many times. In all the cases, will be how are we repeating this? Just by changing the angle of incidence, we will be repeating the experiment. In all the cases, you will be getting same value for refractive index, and that is the verification of second law, which comes for the laws of refraction. Okay, so is it clear about the verification? So from here we will get the refractive index of the glass. Okay. Our next topic is refraction through a rectangular glass slab. So same thing comes under the heading experimental verification, isn't it? So we are going to repeat the same thing now. That is what happens or how refraction takes place through a rectangular glass slab. So I have considered a rectangular glass slab. Then let me name it as A, B, C, D. Now, what is the name given for this light ray? Let me name it as PQ. And what is the name given for this? It is the incident ray. So we are considering a ray of light PQ which hits on the surface AB of a rectangular glass slab. Okay. Now, here I have the normal. The ray is moving from a rarer medium to a denser medium. So what happens? Naturally, it bends towards the normal. So what is the name given for this ray? QR. It is known as the refracted ray, isn't it? So PQ is our incident ray, QR is our refracted ray. Now, here also I have drawn the normal. Now the ray is moving from a denser medium to a rarer medium. So what happens? It bends away from the normal. So let this be S. Okay. So this is what happens to the light ray when it passes through a rectangular glass slab. So I have considered a rectangular glass slab ABCD. PQ is the incident ray which hits on the surface AB. Then QR is the refracted ray and RS is known as the emergent ray. Okay, RS is the emergent ray. Now, the angle between the incident ray and the normal is angle of incidence. The angle between the refracted ray and the normal is angle of refraction. And the angle between the emergent ray and the normal is angle of emergence. Then, since refraction takes place at two parallel surfaces, this angle, here also we are getting an angle, isn't it? These two angles will be same. Okay. Since refraction takes place at faces AB and CD, these two angles will be same. Then, the next thing is, according to principle of reversibility of light. So in the last video we stopped with principle of reversibility, isn't it? So do you remember what is principle of reversibility? The path of a light ray is reversible, isn't it? So according to the principle of reversibility, this angle of incidence will be equal to angle of emergence. Okay. According to the principle of reversibility, angle of incidence is equal to angle of emergence. Then, so what happens? This ray, incident ray, PQ will be parallel to the emergent ray, RS. Okay. So, this diagram is important. It can come for the exam. That is to draw or show the refraction of light through a rectangular glass slab. So you have to draw it and mark the entire thing. And what all things you have to remember here? That is, since refraction takes place at the two parallel faces, these two angles will be same. Then the next thing is, according to principle of reversibility, angle of incidence is equal to angle of emergence, and therefore the incident ray is parallel to the emergent ray. Okay, so these two things should be there in your mind. Is it clear? Now, here you can see that if no glass lamp was there, the incident ray would have gone like this, isn't it? Since the glass lamp is there, the incident ray have undergone refraction and it bends towards the normal. If the glass lamp was not there, it would have gone like this. So, actually the emergent ray is displaced from its original path, isn't it? ഇവിടെ ഗ്ലാസ് ലാബ് ഇല്ലെങ്കിൽ ഇത് നേരെ പോകേണ്ടതായിരുന്നു. പക്ഷേ സിൻസ് ഗ്ലാസ് ലാബ് ഇസ് ദേർ, അത് അതിന്റെ പാർട്ടിൽ നിന്നും കുറച്ച് ഡിസ്പ്ലേസ്ഡ് ആയി. That is, when you are extending the incident ray, you can see that there is a gap or a distance between the incident ray, direction of the incident ray, and path of the emergent ray. And this perpendicular distance, okay, this perpendicular distance between the path of the emergent ray and direction of the incident ray is known as lateral displacement. It's very important. What do you mean by lateral displacement? The perpendicular distance between the path of the emergent ray and the direction of the incident ray can be called as lateral displacement. So, is it clear? Since the glass slab is there, the incident ray actually gets deviated from its original path. So, we will be getting a distance, a perpendicular distance, or a distance is there between the incident ray, direction of the incident ray, and the path of the emergent ray, and that perpendicular distance is known as lateral displacement. And this lateral displacement depends on three factors. Okay, lateral displacement depends on three factors. First one is the thickness of the slab. This question also came many times for the board exam. Name the factors on which lateral displacement depends and how. State how does this dependence hold. Okay, lateral displacement എന്തിനെയൊക്കെയാണ് ഡിപ്പെൻഡ് ചെയ്യുന്നത്, എങ്ങനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു? That was the question. It came many times for the board exam. So, the first factor is thickness of the glass slab, and it is directly proportional. If the thickness of the glass slab increases, lateral displacement also increases. If the thickness of the glass slab increases, lateral displacement also increases. Now, the second one is angle of incidence. It's also directly proportional. That is, if the angle of incidence increases, lateral displacement increases. And the third one is the refractive index. Lateral displacement increases with the increase in refractive index. So, it's very easy to remember. Lateral displacement depends on three factors and it is directly proportional to all the three factors. Okay, so which are the factors on which lateral displacement depends? It is thickness of the glass slab, angle of incidence, and the refractive index. And in all the three cases, the dependence is direct. That is, it is directly proportional. Lateral displacement increases with the increase in thickness, increase in angle of incidence, and increase in refractive index of the glass slab. Okay, so is it clear? Study the diagram, study the factors affecting the lateral displacement. Okay, next one is multiple images in a thick glass plate or a thick mirror. So, if you are using a thick mirror or a thick glass plate, you will be getting many number of images. Okay. So, here I am considering a thick glass plate. Okay. This is a thick glass plate. And if you keep an object in front of it, then many light rays, isn't it? From a single object, many number of light rays will be coming out. And here, if it is normal incidence, if a light ray hits on this mirror normally, what happens? It will go without any deviation. But if it is oblique incidence, in that case, many number of images will be formed. So, we will check how these images are formed. Is it clear? So, we are taking a thick plain mirror or a glass plate. Then we are keeping an object in front of it. So, many light rays are coming out of it and we are considering two light rays. Okay. First one is normal. So, let me name this as AB, CD. Okay. So, this is our object, illuminated object. That means which emits light. So, this object is emitting light in all the directions, and first we are considering the light which hits on the surface normally. So, what happens? And one more thing, this is our mirror. So, this is the silvered part. Silver coating is DC. Okay. So, when a light ray hits on the surface AB, what happens? Since it is normal incidence, no deviation will be there. It will go straight. It hits on the surface CD and it retraces its path, isn't it? So, in the case of normal incidence, the ray retraces its path. It will go on the same path after reflection. Now, we are considering another light ray. And what type of incidence is this? This is oblique incidence, isn't it? So, a light ray hits on the surface AB obliquely. Now, what happens is, some part of the light ray, when it hits on the surface AB, when a light ray hits on a surface, it can be reflected as well as refracted. So, a small portion of the light ray gets reflected. Okay. So, a small portion will be reflected from this part, and it is just a small portion. Nearly 4% of the light ray gets reflected. And what happens to the remaining part? It gets refracted and hits on the surface CD. Now, due to this refracted ray, a virtual image is formed. Okay, we'll be getting an image. Let me name it as A1. And this image will be actually a faint one. Oru mangya image aayirikkum. Why? This is formed due to a small percentage of light ray. Only a small percentage of light ray gets reflected from the surface AB. Adu karanam form cheyna image aayathukonde this A1 will be a faint one. Okay. Now I told you the remaining light ray gets refracted at the face AB and it enters CD. So this is our silver part. So what happens? The ray gets reflected. Okay. The ray gets reflected and it hits on the surface AB. When it hits on the surface AB, some part of the light ray gets refracted and some part gets reflected again. Okay. DC il vanna ആദ്യം hit ചെയ്തു. അവിടെ നിന്നും the entire light ray gets reflected and it hits on the surface AB. AB യിൽ എത്തിക്കഴിഞ്ഞപ്പോഴത്തേക്ക് some part of the light ray gets refracted and some part of the light ray gets reflected. ഇനി ഈ refract ചെയ്തത്, due to this ray, what happens? We will be getting another image. This is image A2. Okay. And this image will be the brightest image. This process will be continuing. It hits here. Then again what happens? It goes there, gets refracted. Some part gets reflected. And here again you will be getting the next image, A3. And this will be continuing. Okay. And in this, the second image will be the brightest. First one, already I told you, it's very faint. What is the reason? Because it is due to a very small part of the light ray. But the second one, ബാക്കിയുള്ള light ray മുഴുവൻ CD യിൽ വന്ന് hit ചെയ്തു. അത് കഴിഞ്ഞിട്ട് from there it gets reflected and hits on the surface AB. From there a small portion of the light ray gets refracted. ഒരു partial refraction takes place and partial reflection. Okay, പകുതി ray refract ചെയ്യുന്നു, പകുതി ray reflect ചെയ്യുന്നു. And the image which is formed due to this is A2. And that will be the brightest image. പിന്നെ വീണ്ടും what happens? ഈ reflected ray hits on the surface CD. Again it gets reflected. ഇതിവിടെ എത്തിക്കഴിയുമ്പോഴത്തേക്ക് വീണ്ടും partial reflection and partial refraction. And this will be continuing. പിന്നെ താഴോട്ട് വരും തോറും the image will become what? Less brighter. And the second one will be the brightest. And do you know what is the reason? The reason is it is due to the light ray which suffers maximum, or the light ray which suffers strong first reflection. Okay. So this question came once or twice for the board exam. In the case of a light ray hitting on a thick mirror, multiple images are formed. So which one is the brightest one and what is the reason? So which is the brightest one? The second image is the brightest one. And what is the reason? The reason is it is due to the light ray which suffers first strong reflection. Okay. So no need to by heart the diagram. You should know the answer for this question, what I have asked now. So is it clear? Once again, we were discussing about the multiple images formed by a thick plain mirror or a glass plate. So I have a thick mirror with me. I have kept an object in front of it. So many rays are coming out. We are considering two rays. First one, normal incidence. Without any deviation, it will go back. Then second one, oblique incidence. When it hits here, a small part gets reflected and the rest gets refracted. ഇനി ഈ റേയിൽ നിന്നും ഫോം ചെയ്യുന്ന ഇമേജ് ആണ് A1. Since it is due to a small portion of light, it will be faint. ഇനി when it hits on the surface CD, it gets അത്രയും കൂടുതലും റേയും CD-യിലാണ് വന്ന് ഹിറ്റ് ചെയ്യുന്നത്. And that entire ray gets reflected and hits on the surface AB. And from there, partial refraction and partial reflection takes place. And we'll be getting the image A2, which is the brightest one. Okay, so is it clear now? Now children, already I asked you to complete question answers till question number 17. So from 18 onwards, answers are given in the textbook. So start from question number 24 as homework. Okay, question number 24 to question number 28. So in between, for one question answer is given that you don't want to copy. Okay, other question answers you have to. That is question number 24, 25, 26 and 28. It should be there in your notebook. Okay. And one more thing, study the questions. All the question answers which comes in exercise 4A. So is it clear? Give importance to the textual questions. Complete the homework. I don't want the lecture notes. I need just the question answers. So write the question answers and upload in the Google Classroom. Then study these question answers before the Google Meet. Okay, so thank you.